Date: September 2023. An opportunity had arose. An opportunity to build projects, a lot of them. An opportunity to gain experience, increase my project portfolio, and get paid while doing it. With that in mind, I took it and I locked in. As a result, I worked on over 20 engineering-based projects, from an IoT greenhouse to a remote-controlled solar-powered vehicle to a pipe inspection robot, and many more, taking on 3D modeling, electrical and electronic circuit design, microcontroller programming, and IoT integration roles across these different projects, most times doing all these roles per project. Now, 20 projects in 6 months sounds like a lot, right? And it was. Just to emphasize, I was working up to 18 hours a day sometimes, and I even pulled 36 hours straight a couple of times, with power naps of course, just to make sure that I don't run insane, to keep up with deadlines and to deliver everything on time. Keep this in mind, I did this while attending lectures, not missing one, and doing all assignments and tests, which led to my GPA for my last semester in university being a 4.72 out of 5, and my cumulative GPA for everything being just 0.4 points less. Now, if you're watching this, you came for something. Either you're looking for great project ideas to try out, designs for a build, advice on how to do so many projects within such a short amount of time, or maybe the combination of what I learned from taking on such a task. And if you clicked for any other reason, let me know what it is in the comments. I'm curious. I'm making this video to encourage rapid prototyping of your ideas with whatever you have at hand. I'm saying it is possible with enough work. Because there's so much to go over, I have to structure this video appropriately in this manner. First of all, I'll list out all of the projects and give you a brief summary of what it was, briefly discussing them with the following criteria. What was the project's aim? Details of how the project worked, including all its features, cost rating, difficulty rating, learning curve if there was any, my favorite part of the project, then a percentage rating on the success of the project, and finally what the final result was. All of this evaluation will be from my perspective, so it has a subjective based nature to it, and you may not agree with me on everything. Since this might take a while, I'll split this video into 2 parts. For everyone watching, I'll be making the most commented project, so comment below which project was your favorite. Alright, here are the different projects I worked on. First of all, an automated window with light, rain and smoke detection, a biometric and barcode attendance system, a Bluetooth and gesture controlled robotic arm project, a haptic-enabled gesture controlled robotic arm, a wearable health monitoring system for emergency response, a solar-powered greenhouse monitoring system, a pipe inspection robot, a pipe leakage detection robot system, a solar tracking system, a solar-powered RC vehicle,
1,000 years later,
a fish tank monitoring system, an automated parking system, a mosquito extermination device, a railway inspection robot, an automatic fluid mixing machine, a proximity glass for the visually impaired, a biometric voting system, a traffic light system, an automatic wireless charging system for electric vehicles, EVs, a warehouse delivery robot, a metal trash sorting system, and finally a piezoelectric shoe for recharging devices in emergency situations. Let's delve right in. But before that, if you made it this far, I want to say that this is a culmination of my work over a finished period of time, and I'll appreciate it if you subscribe to the channel and turn on notifications so you don't miss any more of our videos that are like this, as it supports me and the channel to keep on going. And if you want to see more videos in this style reviewing my work, please drop a comment recommending it, as most of the normal videos here is building tutorials. So yeah, I'd love to see if this kind of video is really appreciated. Now subscribe or you short your next circuit like Mendy.
Output ground, which is, I think, this.
Starting off light, we have project 1, an automated window with light, rain and smoke detection. The project aim was to develop a prototype window that can open and close automatically using a linear actuator. It also sports a smoke sensor, rain sensor and LDR to measure light intensity, so it can perform the following functions. 1 is to close the curtain when the sun intensity is too high and raise it when it's too low. Open the window once smoke is detected if it already isn't open, and to close the window when it's raining on water detected falling inside. The cost rating for this project is a 6 out of 10 because it entailed metal fabrication for a small frame to hold up the aluminum and glass slide, along with all the other components to perform precise control. The difficulty rating for this project is a 6.5 over 10 because of the actual implementation of the control for the curtain that can sway around, because the motor didn't have any encoder and feedback inbuilt, which was indeed stressful. For me personally, there was none of a learning curve because I worked on electronics and control implementations and not on the metal frame and welding, so mostly just 3D modeling and some stuff I'm used to. My favorite part of this project was figuring out a way to implement cutting height control without an encoded motor, which in the end I ended up using an ultrasonic sensor, and mind you, this only works because it was an isolated system and was definitely not perfect. My percentage rating for the project would be 98% because it was complete, and I wouldn't say 100% because I could have made a bunch of improvements here and there to optimize the system. The final result was an automated window with light, rain and smoke detection and the corresponding window control for these situations. Overall 6.5 over 10 wasn't difficult enough to earn a higher score, in my opinion. Project 2 and 3. Now I know you're wondering why 2 and 3 are combined, but because of the sheer number of projects and the similarity between these two, I grouped them together. The two projects I'll be discussing are 1. A haptic-enabled gesture control robotic arm, and 2. A Bluetooth app and gesture control robotic arm. Similar, right? These projects aim to develop a prototype of a 5 degree of freedom robotic arm using MG996R servo motors along with a lightweight metal frame that came as a kit due to lack of fabrication time and equipment. Now, while one project focused on developing a Bluetooth app and gesture control system via a glove using accelerometers and flex sensors, the other focused on a similar gesture control robotic arm but with force haptic feedback for the claws, which would give the user the feedback as to what forces the claws applied related to what degree of movement had been made. The cost rating for these projects were both a 7 out of 10 because the components from the motors, flex sensors to the power supply were relatively costly. The difficulty rating for these projects were a 7.5 for the Bluetooth and gesture controlled robotic arm and an 8.5 for the haptic-enabled one respectively. The learning curve wasn't steep as it wasn't my first time building robotic arms, but definitely during the process of integrating all the features, haptic feedback and control methods, I learned to apply a lot of methods and techniques in control and programming that I hadn't applied before. My favorite part of the project was the electronics and programming, coordinating with the motor movements. Now, from my perspective, the Bluetooth and gesture controlled robotic arm was 95% complete, with the 5% for the fact that I felt like I could make smoother motor movements, while on the other hand, the haptic-enabled one was 90% complete for the same motor movement issues, and the force feedback worked, but was still lacking in calibration. So the final result were 2 robotic arms that achieved the gesture controlled, Bluetooth and haptic feedback respectively, as intended from their designs. Overall, it was an 8.8 over 10 because improvements could have still been made for a lot of features. Project 4. Biometric and Barcode Attendance System. This project aimed to develop a prototype biometric and barcode attendance taking system that used a student's fingerprint along with a barcode on the already existing student ID cards to control access to school facilities, now to allow the university lecturers and staff know who attended what classes and at what time they did by logging that data. It could also be programmed to stop individuals from entering the class after a set time to curb lateness and poor punctuality, as it had a solenoid door lock. So the cost rating for this project was a 4 out of 10 because the components weren't really expensive, just the barcode scanner. And the difficulty rating for this project is a 5 out of 10 because I only worked on electrical and 3D design. I did start on the hardware implementation, but due to some difficulties I was unable to work on said project. For me personally, there was no learning curve because I worked on the electronics and 3D modeling, and that wasn't too difficult compared to what I usually do. My favorite part of the project was the 3D modeling, as it was one of my first times doing animations and joints in Fusion 360. The percentage rating of success of the project was 35% because at the time I worked on it, it was not being implemented and just designed. So final result will be from my end a completable viable design and nothing more than that. So overall 3 over 10 as it wasn't worked on to get even a higher score. Project 5. A wearable health monitoring system with emergency response. The project aimed to develop a wearable health monitoring device with emergency response capabilities, all made into a small form factor build. It was also made to be rechargeable via USB-B port. The device was mounted on a glove as a prototype, although it was supposed to be a watch. It was capable of using an accelerometer to detect falling, a heart rate sensor, and a temperature sensor to detect heart rate and body temperature. It was supposed to have an onboard GPS, but that was escalated after some difficulties. If the system detected a low heart rate or a fall, it would ask the user via a small OLED screen to select whether they wanted to call emergency services or not. And if they didn't make a selection within a set time frame, it would automatically place a call to alert emergency services. It was also supposed to be connected to a website platform with a database, meaning all your health data could be stored and tracked. The cost rating for this project is a 5.5/10 because the components weren't really expensive, but some parts like the GPS, flat LiPo batteries and sensors did have some substantial cost. The difficulty rating for each project is a 7/10 because it had to be made into a small form factor, and doing that on a Wearable board and then soldering it was quite tasking. It also had a UI that had to account for user inputs and a program that was responsible for collecting all sensor data and handling the user inputs too. For me personally, the learning was mostly done on the programming end to optimize the device's accuracy and response time to faults, along with analyzing sensor data and user interactions. I also got to improve my soldering skills too. My favorite part of the project was the small form factor soldering and the program I wrote for it. The percentage rating on success of the project would be an 85% because it lacked the initial intended GPS and IoT integration was not exactly complete, making up for that 15% that was lost. The final result was a functional design, but with a lot of kinks that could have been worked on. So overall, it's a 7/10. I enjoyed working on a bunch of aspects of this project, especially seeing my optimized code work. Project 6. A solar-powered greenhouse monitoring system. The aim of this project was to create an IoT-based greenhouse monitoring system that was able to read the temperature and soil moisture of the greenhouse soil and send that data in real time to an IoT platform, which in this case was a Node-RED user interface, allowing the owner to know what the soil moisture and temperature state of the greenhouse was in real time. It also has an automatic plant irrigation system that powers on when the soil moisture is below the programmed load threshold. This irrigation system can also be manually controlled to come on or go off. To top it off, the system also powered an AS32 camera which allowed visual feed from the greenhouse. All of this is then solar powered, having a solar panel, MPPT solar charge controller and a lead acid battery. It was also equipped with a solar tracking system to ensure maximum solar energy collection. The cost rating for this project is an 8.5/10 because it combined building a wooden model greenhouse, having the greenhouse monitoring system, water tank and pump for irrigation, and also a solar power system all in one. The difficulty rating for this project is a 7.5/10 because it had a lot of integration of different parts that had to work individually and then in synchronization with each other. For me personally, the learning was mostly done on the programming of Node-RED to get it exactly the way I wanted to work on its bunch of features. My favorite part of the project was the Node-RED IoT integration. Now, the success rate of the project was 98%, with only 2% stemming from the fact that the S32 camera's footage wasn't integrated directly into the Node-RED dashboard due to the availability of time. The final result was a fully functioning greenhouse monitoring system, all powered via solar energy. Overall, a 6.5/10, as I enjoyed working on this but had a lot of minor discomforts while doing it. Project 7. A pipe inspection robot. For the 7th project on this list, it's pretty straightforward. A robot that inspects pipe conditions. Simple, right? But seriously though, this was one of the most tasking projects I did. It was a robot that was designed to sit in the pipe by applying pressure on 3 sides of the wall of the pipe, allowing it to situate itself in the middle, and then have a camera in front for visual inspection, while having ultrasonic sensors around the robot to check the relative depth of the pipe for any dents, openings and obstructions. The idea is that a precise version of this robot using high quality sensors like LiDAR can aid in detecting faults in these large pipes. The robot was fully remote controlled with a bidirectional remote controller built using an Arduino Nano and a pair of NRF24L1 transceivers that allowed the sensor data to be read on a PC screen via USB serial communication to the remote control. The cost rating for this project is a 9/10, relative to the other projects on this list because it combines a bunch of 3D printing which isn't cheap around here and had a lot of motors to drive all the wheels, paired with an Arduino Mega to use 6 ultrasonic sensors and not to even add the remote control too. The difficulty rating for this project is a 9/10 because of the intricate 3D modeling and printing that had to be done, and because the prototype was made too small for any room to do electronics, and I mean too small. It was so bad that the robot stopped working on several locations and repairability was 0. So because of that, I enjoyed the build, but it was also a hassle just doing the wiring alone, and because of there was 0 repairability, it was a pain. For me personally, the learning was mostly done on getting the huge amount of wiring to fit just inside a tiny space with what you could say was a design flaw, but really it was literally just traumatizing to fit it all together, and with it responding one moment and not the next, it practically had 0 repairability, and whenever it shut off, it was a pain to just get it working once more. My favorite part of the project was seeing it move because it was such a pain to get done in the first place. Now, the percentage rating of the success of the project is a 90%, simply because it was completed with 100% of all of these features, but because of the zero repairability, whenever it stopped working, it was a pain to get it to work, and because of that wasn't fixed, I decided to give it a 90%. The final result was a prototype robot that actually could inspect pipes, and was pretty decent at its job. Project 8, the Pipe Leakage Detection System. This is one of the simpler projects on the list, and as the name implies, it is a project meant to detect the presence of leaks between 2 points in a pipe by checking for the flow rate at one end of the pipe and comparing it to the other end of the pipe. If there was a leak, a drop in flow rate would occur as water would be diverted. Then the system would alert the operators about the leaking section. The cost rating for this project is a 4 out of 10, as it was simply set up using flow rate sensors, a microcontroller, pipes, a water source and pumps with a bunch of fittings and all. The difficulty rating for this project is a 4 out of 10 because it was pretty straightforward and easy to implement. For me personally, the learning was on flow rate sensors and how they worked, as it was pretty intriguing how they used the hardware interrupt pins to operate the counters. My favorite part of the project was seeing it work as it operated seamlessly as intended, and the percentage rating for this project was 100% as it worked flawlessly, while the final result was a viable leak detection system. Overall rating is a 7 over 10 as the wiring, electronics and code were pretty straightforward. Project 9, a solar tracking system. Now, I'm not going to go over this project because I have an entire video covering this exact same project in detail. It's old, but it explains everything you'd need to know pretty well. So let's move ahead. The cost rating for this project is a 5 out of 10 as it was a simple setup having a solar panel, MPPT charge controller and lead acid battery alongside a frame and servo-driven mechanism with LDRs. The difficulty rating for this project is a 3 out of 10 because just like the last time, it was pretty straightforward, and because it had nothing new that I didn't know, the learning curve was also pretty much none. My favorite part of the project was mostly in getting it to work on a much bigger scale than I had previously done. Now, the percentage rating on the success of this project is 100% because it was completed with nothing missing and nothing to be upgraded. The final result was a single axis solar tracking system. Its overall rating is a 5 out of 10 because I had done it before and there was pretty much no new thing coming toward me. Project 10, a solar powered RC vehicle. Now, for the last project in this video, I worked on developing and designing a fully solar powered remote controlled vehicle, of course a scaled down one. Taking some inspiration from the shape of a Tesla Cybertruck, the RC car had an 18 watt 12 volt solar panel on board with an MPPT charge controller and a lead acid battery which powered the remote control and motor control system that was based on an Arduino Nano and an NRF24L1 transceiver which was used for the receiver and also the transmitter remote control. The cost rating for this project is a 7 out of 10 as the major costs were in the aluminum frame for the scaled down vehicle and the motors, also including the solar power system too. The difficulty rating for this project is a 5 out of 10 for me personally because it combined experience on solar power and radio remote control development which I'm already used to. And if you want to see a more in-depth explanation of the radio remote control, I used it when I built a gesture controlled robot, which you can see here, and the model plane which I would be reattempting soon, which you can see here. For me personally, the learning curve wasn't really existent because I already did things that I already done before, but this time there was also the case of analyzing how the system performed in calculation versus in reality. My favorite part of the project was the actual speed of the vehicle, and from my perspective the project was 100% complete as it hit every single marker spot on. The final result was a fully functional remote controlled solar powered vehicle. Overall an 8 out of 10 because I enjoyed working on it as it was a comfortable and a complete build. On that note, we've arrived at the last project for this video, bringing this to a close. And if you enjoyed this, you can like, share and comment, and if this video does well, we'll do a part 2 on the remaining projects. But all in all, doing so many projects taught me that you can actually push yourself to do a lot more than you think. The more you know that you don't know, and also that you are more capable than you might realize and give credit to yourself for. Ultimately, I learned that there's not really any substitute for the experience you gain because of the impact is life-lasting. And my advice for rapid prototyping is planning before execution. Use the top-down approach to break down the system and use the bottom-to-top approach to build it up while fixing up subsystems and subsystems as integrating them together, and you'd end up having a fully functional end result. See you guys in the next one. Make sure to
output
subscribe or you
ground,
end up
which
like
is,
this.
I think this